morning. I think we're going to jump a little bit of context. I want to thank Idor for a great introduction to my lecture. His was more or less relatively theoretical, what's new. Mine is mainly from the field, or as Israelis say, from the shetach. What LivePerson learned by trying to do a lot of those technologies, how we're trying to do it. First, a little bit about me. My name is Efim. I am a web architect in LivePerson. I've been with LivePerson for a little bit over 6 years in various positions. When people ask me what I do, basically anything that goes to a browser in LivePerson has to go through my head, I hope. Just to give you some context, this is me at 6 a.m. when 2 kids rush and say, "Daddy, Daddy, good morning." But that's part of life. LivePerson, for people that don't know, connects and provides engagement opportunities between the website visitors and the customers' agents. We serve about 1.8 billion sessions each month. We handle around 150 billion connections each month. And we serve around 70% of all online shopping traffic in the US. And we have around 70% of all financial institutions in the US as our customers. So the word enterprise for us, as Ido said, don't use it as an excuse. We try not to, but this is where our money coming from. So we do have enterprise. We run a software as a service platform. So what does it mean for us? A few things. It's scalable. A new customer can triple your traffic. And I'm not talking like a small SMB customer and somebody comes in. If a bank comes in and does a wide deployment, it triples the traffic of all of your company. It has to be secure. We have, on average, almost one penetration test a day, ran without our knowledge. We have financial customers which visit physically our data centers and demand various certifications and so on. So you can either be cool or earn some money. We're trying to find the golden balance. We have to be stable. That's really goes without saying. On the other hand, we want to be really, really flexible. We want to be able to push changes as fast as possible. We want to be really, we want to adjust to what the customer wants to do. And as developers, what do we want to develop? We want to develop single-page applications, which are fast, which are very modular, which are decoupled and flexible. And this is more or less the talk about our experience trying to build this. LivePerson has 2 sides, as I normally say. We have visitor scale, where we monitor third-party websites with our technology on it and collect information. And we have admin scale. Single-page application kind of mostly applies to admin. However, when you talk about chat and other engagement opportunity, it's a single-page application embedded within the page of the customer, which brings its unique challenges. A little bit of the past. This was LivePerson around 3 years ago. Everything in one server, business logic, UI logic, data protection, security layer. The browser was used just to render the content that was outputted out. About 3 years ago, LivePerson made a very big architecture decision to move away from that architecture model. We're still hopefully in the end of that process. But the server provides only APIs, lots of them, that are responsible for 2 things, data and security, nothing else. When you start realizing the business requirements, apparently most of them are UI logic and a little bit of business logic, but the data protection layer is still the server. All the server does is understands what can be done, when, by whom, and that's about it. So it's a little bit scary for a lot of Java developers in our company. We've been completely Java-driven. I was, I think, the first client-side developer hired by LivePerson. Now we're around 30 client-side developers in the company. So the business is shifting. I'm happy, but I'm gonna have a slide about decoupled architecture, just about the server side, just to cover some bases. We went from one centralized server that did everything, and originally it sounded like it's very flexible and very fast to market solution, but we got to a point where it's a dead end. Anything you touch, you can't know what else will break. So we switched to a collection of APIs, completely decoupled. It really improved. This is like information from the real world. It improved stability a lot after the initial pain points. It improved availability. It improved performance. I always, when I give an analogy, I try to say we went from the Windows world, where you get all or nothing, to more like a Linux toolkit philosophy. You pick the tools you want. Those tools do one thing, but do it extremely well. As a side effect, we were able to do a lot faster release cycles. Our old platform would get about 2, maybe 3 releases a year. Now we can release bi-weekly, and bi-weekly only because of a lot of security and legal implications. We actually have to notify our customers and give them heads up about a week before we release. So today we're on bi-weekly release cycles. Now coming back to my favorite part, we also did a lot of work on the client side. It used to be spaghetti. For people that are familiar with jQuery and stuff, it used to be jQuery callbacks that call other callbacks, that call other callbacks, that call other callbacks. Infinite in a lot of complicated UI cases. And we completely rewrote the UI, and we got to what we call a lasagna code, because it is decoupled, it is separate, but we divided it all in JS APIs. We have modules, we have objects, we have SDKs. They're all decoupled, they don't talk to each other. However, there is one problem. They all end up in one browser window. Now, for Java people or server-side people, it's one browser, one window, one thread. Everything that runs in a browser runs on one thread, unless you start using web workers, which not everything you can do there, no DOM manipulations. But we do use wherever we can. So we started with decoupled architecture. We actually finished with coupled deployment. So you start thinking decoupled, but in the end of the day, it's all shared resources. So it is really one of our problems that we had to encounter. Several problems that I'm going to cover that we had to tackle and solve. One of them is code separation. Second one is tooling, resource management in the browser window, and browser to server communication. But before I go, how many people program in JavaScript? Like daily? Okay. That was the first challenge in LivePerson. How do I explain JavaScript to Java programmers, which have been doing it for 10 years, and they're extremely professional, extremely proficient, and for them JavaScript is weird, strange. For me it means flexible and powerful. The everywhere, I think, is a threat for them, because it is now everywhere. Just to illustrate the weirdness, this is JavaScript. If you run this in a browser, it will actually pop an alert with 1. If you're interested how it works, you can go to this website. I'm not sure I should say it out loud, but it is a real website. It is native JavaScript. There are no tricks. It is JavaScript, but it uses the peculiarities of JavaScript. JavaScript is one of those languages where it's very easy to write bad code. It's a lot harder to write good code. It requires a lot of discipline. Mainly because of the next reason. The tooling is in its infancy. Just a couple of years ago, even IE didn't have any way to debug. Or the debugger they started bringing out was a pain in the butt to use. We have a saying, if we have a bug in client side and it's reproducible in Firefox or Chrome or Safari, we can fix it very, very quickly. IE, it can drag on for weeks. And I'm not joking. There are no tools. You're blind. You're back to, I don't know, the dawn of programming, where you're resolving to putting alert lines, and it's not really productive. I think I couldn't find the reference, but I think Douglas Crockford said this quote: "It is the only language that developers think they can program without learning it." It looks very similar. For some people, it looks, oh, it's almost like C without all the pointer stuff. For some people from Java, oh, I can just read the code, I understand. When they start writing it, spaghetti comes out. So it is a language you have to learn. The differences are critical. And it was a very, very big problem or challenge, we're supposed to say, in the company. It took time for server-side developers to accept this world. The last line on this, it's here to stay. Like if somebody entertains an idea that this weird language will go away, just imagine, and do stop me, try to stop me when it gets to a science fiction level, that Microsoft, Google, Mozilla, Apple, they actually sit at one table and actually agree on something. And that's the only way if they can change the language, if they all agree. Even JavaScript, the way it sneaked in, if you look at its history, it just sneaked in behind everybody's back. And then Google realized that they can actually write some cool stuff there to piss off all other companies, and they gave it a speed boost. And then Firefox followed, and then IE was forced to follow. So it's there, and it's actually making big inroads into the server. Node.js is here. It's still at the beginning. We haven't seen the end of it. I don't think we are even in the beginning. It's really, really just out there. It generates tremendous interest. The same guy now can write an application both in the client side and server side, and he's not a server side guy. He's a client side guy. So whoever is purely server side programmer, you should learn JavaScript. Your job is really a little bit at risk. Not yet, but you should know the world. Coming back to the problems we had and the spaghetti code, the immediate thing that we wanted to solve when we moved away from jQuery spaghetti was dependency management. Use require.js, use common.js. I am not propagating here the tools. Use one of them. The initial reaction, even for some JavaScript developers, is, what the heck is this? Why? It really, really, really pays off. The productivity goes up, the reuse of components, they actually kind of force you to write better code because each file should expose only one object. As Ido said, use MV providers, any one of them. We use Backbone. Ido is really proposing Angular, to each its own. It's not pure MVC. MVC doesn't survive translation into web browsers purely. It's MV star, and each one interprets the star slightly differently. Just choose what is really important for you. The links that Ido gave are great. Revealing pattern, hide your private methods and properties in JavaScript. Be like a server-side guy. You can do that now. It looks weird. You think, why the hell I can't debug it in production? But 3 months down the road, you will actually pat yourself on the back and say, wow, thank God I did that. I cannot actually hack my code, even if they do. Because in the end of that road, you get to spaghetti, where you don't know what your change will actually do. Reusable components. This is, for us, was a big hit. It takes a bit of pain in the butt to create because you need to think a little bit more and develop a little bit more. But the speed up you get once you develop the minimum library is amazing. It's like an exponential curve. First you pay the price, then you start running. Unit tests for JavaScript. It's here. I keep getting asked in the company, why do you unit test JavaScript? My only answer is, do you unit test Java? Yes, you do. So what's the difference? Just because I added script to a word and it's still a programming language, I shouldn't unit test? We unit test the hell out of our code. There are quite a few providers. We use QUnit. Automation tests, if you can afford it, if you can, it's a great tool. We almost don't have QA. We do everything automation. We use Selenium for the web stuff. And all you see is the automation guy watching the matrix, where he just tests our application completely. I always call them they do nothing and watch the screens, but there is a lot of work behind it. It also tests it across all browsers. Normally, we don't test every permutation, but we do test major families and the minimum supported version, especially in IE. Our problem is that for admin interfaces, only last year we were able to convince the company to drop IE7 support, and we're still fighting that fight, but at least officially we don't support. On the visitor side, we support IE7 and IE6 to the level that don't break the customer's website. You don't have to work, but detect. Our monitoring, by the way, solution works probably in IE5 still. Maybe not with all the advanced stuff, but the engagement and content, we try to normally IE7, but sometimes IE6 is being phased out in our company, we're trying. But we still get about 7 to 8% traffic. The second problem is tooling. This is really a pain point for me. Use a correct tool for the job. Don't use build tools which were designed for the client side and not server side. Use Grunt, use Yeoman. We had situations where people would use Maven to concatenate files of JavaScript just because that's what they know. And it took them like 2 weeks. Using Grunt, we do the same in about 5 minutes. Concatenate and minify all your JavaScript, CSSs, and HTMLs. If the files get too big, split it, and lazy load them, but don't invent a wheel. You are the best qualified person to know which code should be loaded lazily. You know your application. You just can reconfigure the build tool so that there is the initial application load, and as that finishes in the background, start loading the other stuff. Tools like Require don't even allow you not even to bother with synchronization when it loads or not. Require takes care of it. CSS it's a little bit harder, but it's normally a lot smaller. HTML templates, we even pre-compile them into JavaScript for performance reasons. Compress all output, please. It's just your production people need to do. Your users will really appreciate it. It's a flip of a switch. You don't have to do anything. Just go to your DevOps or production, whatever you call them, and tell them, please compress everything coming out. Compression, you can do it in 2 ways, at runtime by the web servers or other application servers. You can also pre-gzip and use mod rewrite in Apache, where you say if the browser sends a header, I will just get the file with the .gzip extension. It depends on your traffic level. Sometimes you can trade the CPU and get it back. Use code analysis tool. It was very funny in our company. We really put it in without telling into the build process. And suddenly people started, wow, why doesn't it like my code style? There is a reason for it. Sometimes the price for making the code efficient, very, very advanced, is actually the code becomes unreadable. And also, if you've seen, I think on Google I/O there was about how V8 works and all the interpreters. In a lot of cases, if you really try to do clever things in JavaScript, it will hurt the performance as opposed to improve it, because the just-in-time compilers in the interpreters of browsers cannot understand your code anymore. They're saying, you're doing something very, very special, so go in the regular track, where, especially in loops and this, there used to be a lot of articles. By the way, any article you see on performance in a browser, which is more than probably, let's say, 2 years old, ignore it. Really ignore it. It's out of date. It's not really relevant. You can be confused by it. Optimize images during the build process if you really care about performance. And the last, it's a holy grail. Monitor, monitor, and monitor your performance. There are tons of tools. This is just the beginning. There are local tools. There are services. I think Google says if you can't monitor, it doesn't exist. So you cannot say my site or my web page is very well performing. Show me the numbers. It's not the words don't mean anything here. Also, do target the monitoring according to the target audience. Most of the companies are not globally distributed, their audiences, so monitor for real. Resource management. It's coming back to the fact that it all runs in one window. So the biggest problem that normally pops is memory. It's very easy to say don't write code that leaks, but in a lot of cases, even browsers leak. Chrome DevTools is your friend, IE is your enemy, but try. Run your single page applications for at least 24 hours with some sort of automation. You won't believe how many leaks and browser-specific leaks. IE8 leaks 4 kilobytes of memory every time you make a JSON-P request. The second biggest problem we had was number of requests. This is like a golden rule, minimize the number of requests. This came as effect of server-side decoupled. Server people created lots of APIs, all of them on stats, LivePerson.net, monitor LivePerson.net, and so on. The problem was that you get a web page that suddenly needs information to be pulled from 4 or 5 different APIs, sometimes more. Now, straight away, you bump against the limits of concurrent requests. That's not the only thing your web application does. It probably tries to do something else. Processing, delays, synchronization. The only solution here is make your developers work and put a proxy where you tell your proxy, please fetch the following 5 entities and concatenate them into an array of responses and give us for processing. It doesn't really work for real operations like delete and update, but for getting, it really, really helps performance. The last problem that we really encountered was browser-to-server communications, normally to do with cross-domain policies. And because we run 2 sides, and actually we ended up even within our own side having multiple different domain APIs, I'll just go through a few technologies. Ajax, great, same domain only. That's it. It's a great technology. If you're on the same domain, same port, same protocol, use it. If you're not, you're stuck. JSON-P, it has been with us for a while. It's fast, it's stable, it's popular. However, it's limited. The limit is 2083 characters. Some browsers accept more. However, a lot of proxies in the world cut GET requests above 3,000 characters, even if your browser allows. And the worst thing is that I think IE, if you issue a request with more than 2083 characters, it just silently fails it, and you don't know that it failed. So there is no way to find it out. We use it a lot. We also have a lot of problems with it. But a new standard came, cross-origin resource sharing, very big hype, a lot of information. We tried, doesn't work. Slow and doesn't work. For us, maybe something has changed in the last 6 months. For our browser matrix, doesn't work. It solves maybe 10% of what we need and requires extra work on the server just for this protocol. And the future for now is uncertain. It's like nobody commits to really supporting it. So we ended up inventing something. We use Ajax together with Postmessage, and it gives us IE8 plus support. Very nice. I'll explain in the next slides how it actually works. For our IE7 and below, we actually just do a post with an iframe and a form inside it, and basically say, well, you might not get the full experience of LivePerson service, but at least we will collect the data about you, and we will act on certain things. We start doing weird things. We do a post and we can't get a response, so we follow it with a JSON-P GET to get that response. But hopefully within a year we'll be able to convince the company that IE7 sucks, so we'll be able to just drop support of it or have very, very limited and minimum support. What we do, this is a regular situation for us. You have a website on url.com. and you want to call API LivePerson.com, what we do is LivePerson.com, yes, hosts a file we call pm.html that contains a post message listener, but it's also a producer, so we call it post message server just because it comes from a server, and an XHR client. On the client side, we have a post message client, and which drops an iframe when needs to. And what happens is your application asks the library to make a request. It understands that JSON-P is not good enough, so it will drop down to using post message. It will initialize the iframe if needed with the source of liveperson.com/pm.html. And then it will use the post message protocol to communicate with that iframe. The iframe, when it gets a message, automatically converts that object or that JSON into AJAX request. It comes back, serialization back, and comes back to the client. It works really well for for a lot of requests. It's very stable. The browsers really support it. It's almost as fast as JSON-P. You pay for the initialization of the iframe per endpoint you use. But if you're not doing one call, that delta really diminishes on average. The biggest thing for us was we can use RESTful services. In Java, people understand REST now, so they write REST APIs. We can use it. But few points that we really painfully learned. Beware. 403 response, unauthorized. What it does to a browser, it pops a box, please put your username password. Because 403 actually means you are unauthorized to access this resource with the current credentials. The solution for that is either one, don't return 403, probably you meant 401, just not authorized, or you can play a little bit with the headers on the response, and then the browser would not pop it. But it's a little bit of abuse of the standards, so we suggest you just don't return 403. Yeah. Okay. And as usual, there are always those weird things. If you make 8 consecutive requests in an iframe to the same domain and they all fail, the browser considers that iframe dead. So every new one that iframe will try to issue, it will just abort. Very, very interesting. It was like we opened our eyes and said, what? We actually used other words, but how, what, why? This is one of those things that scares a lot of server-side programmers. You program for an anarchy. You don't know, it's not stable. It might work today and break tomorrow, just because somebody released a new version of the browser. So you just deal with it and accept it as it comes and set expectations that things will break. Just have a very, very quick turnaround to fix it. The fix here is relatively complicated, but the iframe can detect that that's what happened, and it sends a message back through the post message mechanism to the post message client, which would delete that iframe from the DOM and would initialize another one. And then you're back. Again, this is a workaround. 8 consecutive error requests is not that common. You can pre-optimize that before, because you can count how many consecutive you're failing. So on the 7th, you say, well, I better tell the client to spawn another iframe on the side. That's really performance optimizations. I think I'm done. As usual, if any of it sparked your interest, talk to me. We're hiring. Thank you. If you have any questions, please ask.